If your Excel report breaks right after a refresh, you're not imagining it. One refresh can silently change a column from a number to text or from date to general. Then, formulas miscalculate, pivots split values, and charts jump around. The frustrating part is that the data looks fine at first glance. The real issue is schema drift. Excel reinterpreting your columns when the incoming data shifts. Maybe a blank appears, a new code shows up, or a single non-numeric value sneaks into a numeric field. Excel tries to be helpful, but for reporting it can be destructive. The fix is not a single button. It's a set of habits that lock the schema and make refresh predictable. That means controlling types at the input step, validating after refresh, and designing reports that fail loudly instead of quietly. Let's turn refresh from a gamble into a routine you can trust. Next step. First, let's get clear on what column type really means in Excel-connected data. When you import external data, Excel and the connector decide how to interpret each column. Is it a whole number, a decimal, a date, a true text ID, or a blank? That decision affects everything downstream. A numeric column can be summed, a text column cannot, even if it looks like numbers. Dates are especially fragile because they can arrive as real date values, as text like 2026-05-12, or as locale-specific strings. During refresh, Excel may rescan the incoming rows and choose a different type than last time. That's why a report can work for weeks, then fail when one odd row appears. If you only format cells, you're not fixing the underlying type. Formatting is cosmetic. Type is logic. To prevent broken reports, you need to control the logic at the source of the import, not just the appearance in the sheet. Next step. Here are the most common triggers that cause Excel to change types on refresh. The first is mixed content, a column that is mostly numbers but contains one dash, one space, or one word will often become text. The second is leading zeros, like product codes or zip codes. If Excel decides it's numeric, those zeros disappear. The third is nulls and blanks. Some connectors treat blanks as text, others as null, and Excel may change its guess, depending on how many blanks appear near the top. Another trigger is a new value pattern, like an ID that suddenly includes letters. And finally, regional settings. A decimal comma versus decimal point can flip numbers into text, and date formats like 03/04 can swap month and day. None of these are rare edge cases. They happen in real data all the time. So the goal is to build a refresh pipeline that expects imperfect data and still produces stable, typed columns. Next step. Before you lock anything down, you need to know where the type decision is happening. In many setups, it's Power Query, also called Get and Transform. In others, it's an older connection like Microsoft Query, ODBC, or a direct web or CSV import. The key question is, where can you explicitly set types so they persist? If you're using Power Query, types are controlled by steps like changed type. If you're using an older connection, Excel may infer types each refresh with fewer controls. Also, your report might be built on a table loaded to a worksheet or on the data model. Those paths behave differently. The simplest way to diagnose is to look at the query or connection properties and see whether a transformation layer exists. If you can edit a query, you can lock schema more reliably. If you can't, you may need to add a staging layer in Excel that enforces types after refresh. The rest of this walkthrough gives you options for both situations. Next step. If you're using Power Query, the most important habit is to control the changed type step. Power Query often inserts it automatically based on a sample of rows. That's convenient, but it's also the source of many surprises. Instead, you want types to be explicit and intentional. One approach is to delete the auto-generated type step and replace it with your own type assignments after you've cleaned the data. For example, trim spaces, replace blanks, and standardize date text before you set the final type. Another approach is to keep the step, but edit it so every column has the correct type, including text for IDs that look numeric. Also, be careful with any type. It can defer typing until load, which reintroduces uncertainty. The goal is simple. Your query should declare in one place what each column is supposed to be. Then refresh becomes repeatable, even when the source data has quirks. Next step. Let's talk about the classic failure, numbers turning into text. In Power Query, you can force numeric typing, but you should also decide what to do with non-numeric junk. If you simply change type to number, invalid values become errors. That can be good, because it fails loudly, but sometimes you'd rather convert invalid values to null and keep the refresh running. You can do that by replacing non-numeric patterns before typing, or by using a conversion that returns null on failure. The same idea applies to dates. If dates arrive as text, parse them using a defined locale and a defined format, then convert to a date type. For currency and percentages, keep them as numbers and apply formatting later in Excel. And for codes, SKUs, and account numbers, treat them as text from the start, even if they look numeric. That preserves leading zeros and prevents scientific notation. Stable typing is really about making deliberate choices for each column's intent. Next step. Sometimes the problem isn't typing. It's the source changing shape. A column gets renamed, a new column appears, or the order changes. That can shift your report references and break measures, pivots, or formulas. In Power Query, you can stabilize this by selecting columns explicitly rather than relying on all columns. Use a step that keeps only the columns you expect in the names you expect. If a new column appears, it won't suddenly flow into your model and confuse things. If a required column disappears, you want the query to fail clearly instead of producing partial data. Another technique is to rename columns in the query to your standardized internal names, even if the source uses inconsistent naming. Think of it like a contract. The source can be messy, but your query output should be consistent. That consistency is what keeps reports stable across refreshes and across file handoffs to other people. Next step. If you're not using Power Query or you're stuck with a legacy connection, you can still lock schema, just in a different way. The idea is to separate raw import from report-ready table. Let the connection refresh into a raw sheet or raw table. Then build a second table that enforces types using explicit conversions. For example, use value to force numbers, date value for dates that arrive as text, and text to force IDs into a consistent text format. You can also use helper columns that detect problems, like isNumber, isText, or checks for blanks. This staging layer acts like a firewall. Even if the raw import changes, your report table stays consistent, or it flags exactly what went wrong. Yes, it's extra work, but it's often the only reliable approach when the connector won't preserve schema, and it makes your workbook easier to audit because the logic is visible in formulas. Next step. A big part of preventing broken reports is designing checks that catch type drift immediately. Quiet failures are the worst because they look correct until someone makes a decision based on bad totals. Add lightweight validation that runs every refresh. For example, count how many rows have numeric values in a numeric column. Count how many date values are valid dates. Check for unexpected blanks in key fields. You can also compare row counts and distinct counts against expected ranges. If you use Power Query, you can create a validation query that outputs a small status table, pass, warning, or fail. If you use formulas, create a data health section with a few red or green indicators. The goal is not perfection. The goal is early detection. When something changes upstream, you want to know on the first refresh, not at month end. A simple validation layer turns schema drift from a mystery into a manageable alert. Next step. Now let's connect this to pivots and the data model, because type changes hit them hard. In a pivot table, text 100 and number 100 are different items. That's why you can get duplicate-looking categories or totals that don't add up. In the data model, types affect relationships and measures. A relationship between an ID column and a lookup table can break if one side becomes text and the other stays numeric. Even worse, it can appear to work, but filter incorrectly. The solution is to enforce types before the data reaches the pivot or model. For Power Query to data model loads, set types in the query. For worksheet-based pivots, feed the pivot from your cleaned staging table, not the raw import. Also, avoid building pivots directly on a volatile connection output. Treat the pivot source as a stable interface. When you do that, your pivot behavior becomes predictable and refresh stops being scary. Next step. There's also a reporting design trick that saves a lot of pain. Separate presentation from data. Keep your imported and clean tables in one area, and keep your report outputs, pivots, charts, dashboards in another. Then reference the cleaned outputs only. This reduces accidental edits, and it makes it obvious where to fix issues. Another best practice is to use structured references with tables, not loose ranges. Tables expand predictably and reduce broken formulas when row counts change. And when you have to convert types with formulas, prefer helper columns inside the table so the logic fills down automatically. Finally, document your schema contract in plain language. Which columns are text, which are numbers, which are dates, and which are required. That documentation is not busy work. It's what lets you or someone else troubleshoot quickly when a refresh introduces unexpected values. Good structure is a form of schema locking too. Next step. When a refresh breaks something, you want a fast, repeatable troubleshooting path. Start by identifying the first column that changed behavior, usually where totals drop, blanks appear, or categories duplicate. Then check the raw import for the first weird value, a space, a dash, a mixed date format, or a new code. Next, verify the type at each stage. In Power Query, confirm the final typing step and look for earlier steps that introduce text, like replacing values with strings. In formula staging, check whether value or date value is returning errors. Then decide your policy. Do you want refresh to fail on bad data, or do you want to coerce bad values to null and log them? Both are valid. Failing is safer for finance-style reporting. Coercing is useful for operational dashboards. The key is consistency. Once you choose a policy, implement it the same way across columns so refresh behavior is predictable. Next step. Let's wrap this into a practical checklist you can apply to any workbook. 1. Decide the intent of each column: number, date, text ID, or category. 2. Enforce that intent at the import layer, ideally in Power Query with an explicit typing step after cleaning. 3. Stabilize the shape by selecting expected columns and standardizing names. 4. If you can't control the connector, build a staging table that converts types explicitly. 5. Add simple data health checks so type drift is caught immediately. And 6. Feed pivots, charts, and the data model only from the cleaned, stable output. If you do those 6 things, refresh becomes boring, in the best way. Your reports stop breaking, and when the source changes, you get a clear signal instead of silent corruption. If you want, share your situation in one line: Power Query or legacy connection, and what type keeps flipping. And if this kind of Excel reliability work is useful, subscribe for more practical, low-drama fixes. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.